Welcome to the second video of the chapter Periodic Classification of Elements. The first step towards the development of a periodic table was done in 1817 by Dobrynja through his triads. The limitations in Dobrynja's triads gave rise to Newland's octaves in the year 1866. In the previous video, we had seen that Newland's octaves also had certain limitations. After the failure of Newland's octave in 1869, the Russian chemist Dmitry Ivanovich Mendeleev gave a remarkable contribution towards the development of periodic table. Dmitry Ivanovich Mendeleev. He is known as the father of the periodic table. He arranged 63 elements based on atomic mass. He also considered the physical and chemical properties of elements while grouping these 63 elements in the increasing order of atomic mass. For understanding the physical and chemical properties of the elements, he thought of taking compounds formed by these elements with hydrogen and oxygen. Wait a minute, why hydrides and oxides? It was because these two elements are very reactive and hydrogen and oxygen easily form compounds with all the elements. He started to note down the physical and chemical properties of each element in separate cards. That is, he made 63 cards and arranged these cards on the basis of their similarities in properties. While arranging the elements, he arranged the elements with similar properties in vertical columns called as groups. The horizontal row, which was formed during this arrangement, is known as a period. So, he made a clear explanation for periodic table that it is a chart of elements arranged in such a way that elements with similar chemical properties fall under a vertical column known as group. Let us now understand more about Mendeleev's periodic table. In Mendeleev's periodic table, there were 8 groups and 7 periods. Group 1 to 7 consisted of normal elements. Group 8 consisted of transition elements. The first 7 groups were divided into 2 subgroups, and the last group, that is group 8, had 3 subgroups. An interesting feature observed in Mendeleev's periodic table is that elements having similar properties come in the same group. Take a look at the periodic table created by Mendeleev. In Mendeleev's periodic table, all elements had 2 general formulae, one for their oxides and one for the hydrides. Using this general formula, the formula for the oxides and hydrides of any element in any group could be easily written. Note the general formula depicted here in the Mendeleev's periodic table. In that, the letter R is used to represent any element in the group. Note the way formulas are written. For example, the hydride of carbon CH4 is written as RH4 and the oxide CO2 is depicted as RO2. Now, the formula for aluminium oxide will be Al2O3. You can see aluminium comes in third group and its general oxide formulas are 2O3. So, aluminium oxide's formula will be Al2O3. Do you observe the empty spaces in the periodic table designed by Mendeleev? Instead of considering this as disadvantage, Mendeleev boldly predicted that these empty spaces were for the elements that are yet to be discovered. Not only he left spaces, but he also predicted the properties of these undiscovered elements. Compare the properties of the element germanium predicted by Mendeleev and the actual properties of the element. Surprisingly, the properties of germanium predicted by Mendeleev matched accurately with the actual element characteristics. This provided a convincing proof for both the correctness and usefulness of Mendeleev's periodic table. Mendeleev also observed that there were some reoccurrence of elements with similar properties after certain regular intervals. On this basis, in the year 1869, he proposed his periodic law. Mendeleev's periodic law states that the properties of elements are a periodic function of their atomic masses. To get a clear understanding on the law, let us divide the law into three parts. The first part, properties of elements. Through this, we mean the physical and chemical properties of each element. R, a periodic function. Periodic function means repetition of properties, that is, properties occur at regular intervals of atomic mass. This regularity is seen when the elements are arranged in the increasing order of atomic mass. In other words, when elements are arranged in the increasing order of their atomic masses, there is a repetition of properties after certain intervals of elements. Let us now understand how far Mendeleev was successful in designing his periodic table through his chosen characteristics, atomic mass and physical chemical properties. Moving on to the merits of Mendeleev's periodic table. Mendeleev made a systematic study of elements. This simplified the study of elements, as the arrangement of elements showing similar properties were classified into groups. It was very useful in studying and remembering the properties of a large number of elements in a systematic way. A remarkable advantage of Mendeleev's periodic table was the blank spaces left for the elements that were yet to be discovered. He also gave provisional names by prefixing a Sanskrit numeral to the name of the preceding elements in the same group. For example, germanium, scandium and gallium were given the names as Eka silicon, Eka boron and Eka aluminium depending on their position in the periodic table. The table given beside also show a few more examples for the provisional names given by Mendeleev to the yet to be discovered elements. The greatness of Mendeleev was that not only did he leave spaces in his table for elements that were not yet discovered, but he also predicted the properties of those elements which later were almost same to the real characteristics of these elements. Here you can see the modified Mendeleev's periodic table where the newly discovered elements are also included in the table itself. Another advantage of Mendeleev's periodic table was the inclusion of noble gases. Noble gases were discovered much later, but these elements could be easily placed as a separate group called zero group without making any disturbance to the arrangement of any elements in the periodic table. Why were noble gases discovered very late? The reasons were noble gases have completely filled shells and hence they are inert in their nature. Also, the amount of these gases present in the atmosphere is very less. Mendeleev's periodic table seemed to be convincing in that time, but there were a few demerits or anomalies in his classification too. Moving on to the first anomaly, position of hydrogen. In his periodic table, hydrogen was kept along with group 1, that is alkali metals, due to the similarity in the formation of compounds of hydrogen with halogens, oxygen and sulfur. At the same time, some of the properties of hydrogen were similar to those of the group 17, that is halogens. Similar to halogens, hydrogen can also be found in the form of a diatomic molecule. Thus, Mendeleev's periodic law was unable to place hydrogen in the correct position in the periodic table. The second anomaly was in the position of isotopes in his periodic table. The atoms of same element having similar chemical properties but different atomic masses are called isotopes. Since isotopes have different atomic masses, they should be placed in different groups of the periodic table if the elements were arranged according to the atomic mass. In Mendeleev's periodic table, isotopes were not given their column. The isotopes were arranged in the same place. For example, Cl35 and Cl37 are two isotopes of chlorine with atomic mass 35 and 37 respectively. Mendeleev's periodic law did not explain why these two isotopes having different atomic mass were placed in the same group of the periodic table. Elements like copper, silver and gold were grouped along with highly reactive alkali metals like sodium, potassium and lithium. There are a few anomalous pairs of elements where the element with higher atomic mass has been placed before the one having lower atomic mass. For example, cobalt with atomic mass 58.9 precedes nickel with atomic mass 58.7. Other such anomalous pairs are argon placed before potassium and tellurium placed before iodine, where the element with higher atomic mass precedes the element with lower atomic mass. The next anomaly or demerit in Mendeleev's classification was in placing the lanthanides and actinides. 14 elements that follow lanthanum and 14 elements that follow actinium were not given proper places in Mendeleev's periodic table. Due to these anomalies or demerits, it was felt that arrangement of the elements in the periodic table should be based on some other property which is more fundamental than atomic mass. So what should be the criteria to classify elements? We will be discussing that in the upcoming video. I hope that you have understood the classification done by Mendeleev and how far it was successful. Thank you for watching the video. If you like the video, hit the like button, share the video among your friends and family, and do post your doubts as comments. Subscribe the channel and hit the bell icon for instant notification when the videos are uploaded. Thank you for your love and support.